Hello and welcome to Utkarsh Minds Python for Data Science and Statistics. Today we will see how to apply in Python a test for three or more variables of type ordinal. Since we are working with Python, we will open the Colab notebook and we will create a new notebook here. So this notebook I will give the name paired ordinal 3 or more and connect it, and then I will upload the data set student statistics. Then I need also to import some libraries like pandas, numpy, matplotlib.pyplot as plt. I am uploading the student statistics data set. Then we take the data as pandas.read csv student statistics.csv data.head. Sorry, s is missing. So now the data is read and we have got the entire student statistics here as as the different columns. If you see these columns, these ordinal data that we are interested in is we will select certain columns from this and show you. So selected data, I am taking certain columns from the old data set. These columns are teach, motivate, then comes teach, link, theory, and then comes teach, stim, ask. And let us take one more, teach, avail, and let us see how is the selected data looking like, so that you understand that it is a type of ordinal data. As you can see, it has different levels, but all the levels are same. There are 5 levels in this, and if you want to know what are the 5 levels, each of the column has the same level. I will just show it on one column, but you can replicate this same operation on other columns and confirm that each column has the same levels. Lowest level is fully disagree, then neither disagree nor agree, then agree, and then finally fully agree. These are the 5 columns in the data. So we will have a coding scheme, because we cannot work with this English. We have to arrange this in levels. I will remove this not a number. Fully disagree, then comes neither disagree, then comes agree, and then comes fully agree. These are the different coding scheme. Then we will replace these coding schemes, replace with the help of this coding scheme. So selected data dot replace. Okay, we can replace it like this, the coding scheme, and in place is equal to true. Then just to show you, I will print this data set. What is the output of this? You will see that selected data, nothing has been replaced. Why? Because it will be in the next cell. Selected data, Sorry, because we did not assign here. Fully disagree is 0. Disagree will be 1. Neither this will be 2. Agree will be 3, and fully agree will be 4. So now when I am running, we can see that all the English has been replaced with numbers. We can do some data visualizations and everything, but I am not doing that. I am directly going for the statistical test. The test that we are interested in is known as the Friedman square test, or Friedman chi-square test, or simply the Friedman test. It is an extension of the Wilcoxon signed rank test, something that we had seen in ordinal data testing, but independent or unpaired tests on ordinal data, two ordinal variables. Friedman test is an extension of that, since the Wilcoxon test is applicable only for two variables. So here I am writing Friedman chi-square, and here in Friedman chi-square I am selecting the data. So this is teach avail, and similarly the other columns also we will have to add. There are 4 columns. Just let me see, the names are given here. I will copy the same names. One was teach motivate, one is teach, and one is. With that, our test can be ready for application, and we get the since we are not dealing with null values, we have to remove the null values also from the data. So for that, what we can do is we can write here drop NA in place true, so it will drop the null values, and now we can apply the test. So we are getting a statistic and a p-value. That looking at the p-value, you understand that it is far less than 0.05, because e raised to minus 7, it means that 10 raised to minus 7, so it is very close to 0. The conclusion is that these 4 are not having the same responses. That means there is a difference in the responses received for each of these 4 columns. So students have not given the same review for all these 4 parameters. Now that we know that there is a difference, we need to also understand how big or small is that difference, and that we understand from the effect size, which is known as Kendall W. Now this Kendall W effect size can be calculated if we know how many rows and columns are in the data. So for n we get number of rows, and k is the number of columns. Once we have n and k, we know the statistic, so we take the statistic here and we divide it by n multiplied by k minus 1, and that is our Kendall W test statistic. Now it is shown as 0.21. If it is between 0 to 0.3, then it is weak. If it is 0.3 to 0.5, then it is moderate. If it is 0.5 to 0.7, then it is good, and anything above 0.7 is strong, or you can say relatively strong and then strong. So at the end, we can sum all this into a single report. We can say that the different factors uh, were not having the same, you can say, responses, and after applying the test, applying the Friedman test, the difference was significant. Here we can say the p-value was less than 0.5, and further the Kendall W effect size was or suggests the difference is weak. Here we write W equal to 0.21. That is the report, and with that we have finished one more hypothesis testing, and we can move on to the next topic. Thank you for watching.